Hello friends, welcome to the T.Y.B.Sc distribution theory class. In today's lecture, we will see the another interrelationship of gamma and beta distribution. In last lecture, we have seen the one relation between gamma and beta distribution of first kind. Here, we see the interrelationship of gamma and beta distribution of second kind. So, here we have given that if X has a gamma distribution with parameters alpha and lambda 1, Y has a gamma distribution with parameters alpha and lambda 2, both X and Y are independent, then we want to derive the distribution of u is equal to x upon y. Okay, so firstly what we have given, that we have given the x has a gamma distribution with parameters alpha and lambda. So density function of 8 is f of x is equal to alpha raised to lambda 1 gamma lambda 1 e raised to minus alpha x raised to lambda 1 minus 1, where x greater than 0 and parameters also positive, 0 otherwise. Okay, further we have given that y has a gamma distribution with parameters alpha and lambda 2. So f of y, density function of y, is alpha raised to lambda 2 gamma lambda 2 e raised to minus alpha y raised to lambda 2 minus 1, y is greater than 0 and parameters alpha lambda 2 greater than 0, 0 otherwise. These are the density functions of gamma distribution with parameters alpha, lambda 1 and lambda 2 respectively. Okay, so here we have given that x and y are independent. So joint density function of it is f of xy is equal to f of x into f of y. Okay, your x and y are independent. So that is your joint density function is alpha raised to lambda 1 upon gamma lambda 1 e raised to minus alpha x raised to lambda 1 minus 1 alpha raised to lambda 2 gamma lambda 2 e raised to minus alpha y raised to lambda 2 minus 1. Okay, so that means it is equal to alpha raised to lambda 1 plus lambda 2 gamma lambda 1 plus lambda 2. So here, sorry, this term is just the gamma lambda 1 into gamma lambda 2, not the plus is there. Okay, so this by mistakes into x raised to lambda 1 minus 1, y raised to lambda 2 minus 1 and e raised to minus alpha x plus y, where x greater than 0 and y is greater than 0. This is the joint PDF of x and y. Okay, now we have given that u is equal to x upon y. Since we want to find the distribution of u, so here u is equal to x upon y and we have assumed that v is equal to y. So that means your x is equal to u into v and y is equal to v. Okay, now your x is greater than 0, y is greater than 0. Okay, these are the given information. So that means your x is nothing but u into v, which is greater than 0, and v is greater than 0. If your v is greater than 0, so also your u should be greater than 0, since u into v is greater than 0. So that means your range of u and v are u greater than 0 and v greater than 0. Now further we want to find the Jacobian. Jacobian is nothing but del by x by del by u, del by x by del by v, del by y by del by u, del by y by del by v. So that means your x with respect to u, your x is u into v, so v, x with respect to v, u, y with respect to u is 0 and y with respect to v is 1. So that means this value is v. Okay, so I have just write it as v, and we know that your v is greater than 0, so absolute value of j is, absolute value of v is nothing but v, since v is positive. Okay, now if you want to find the joint PDF of u into v, so we can write it as g of u v is equal to f of xy, joint PDF of xy, where x is equal to u into v and y is equal to v into Jacobian. So your f of x into y is, you can write it as alpha raised to lambda 1 plus lambda 2 gamma lambda 1 into gamma lambda 2 e raised to minus alpha x plus y. So your x is u into v plus v, x raised to lambda 1 minus 1, y raised to lambda 2 minus 1 into your Jacobian is v. That means we can write it as alpha raised to lambda 1 plus lambda 2 upon gamma lambda 1 plus lambda 2 into gamma lambda 1 plus lambda 2 upon gamma lambda 1 into gamma lambda 2 e raised to minus alpha v 1 plus u. Here I have taken v outside, u raised to lambda 1 minus 1, v raised to lambda 1 plus lambda 2 minus 1. This is lambda 1 minus 1 plus lambda 2 minus 1 and plus 1. So only lambda 1 plus lambda 2 minus 1 is there. Okay. Now here I have write it as alpha raised to lambda 1 plus lambda 2 gamma lambda 1 plus lambda 2 1 upon beta lambda 1 lambda 2. Since this beta, we know that beta mn is nothing but gamma m into gamma n upon gamma m plus n. So if I have to take in the reciprocal of it, we get the gamma m1 plus n upon gamma m into gamma n, and here m and n are lambda 1 and lambda 2 respectively, into e raised to minus alpha v 1 plus u raised to lambda 1 minus 1, v raised to lambda 1 plus lambda 2 minus 1. Okay, where u and v are positive. Okay, now our interest to find the distribution of u. So here I have to find the density function of u. So taking the integration with respect to v of this joint PDF of uv is, that is v 0 to infinity, your alpha raised to lambda 1 plus lambda 2 gamma lambda 1 plus lambda 2 1 upon beta lambda 1 lambda 2 e raised to minus alpha v 1 plus u raised to lambda 1 minus 1 and v raised to lambda 1 plus lambda 2 minus 1. So those terms which is independent of v, I have taken the outside, here dv is there. So alpha raised to lambda 1 plus lambda 2 which is the independent of v upon gamma lambda 1 plus lambda 2 1 upon beta lambda 1 lambda 2 u raised to lambda 1 minus 1. Integration over 0 to infinity e raised to minus alpha v 1 plus u into v raised to lambda 1 plus lambda 2 minus 1 dv. So by using the gamma function, we know that integration over 0 to infinity e raised to minus ax x raised to n minus 1 dx is nothing but gamma n upon a raised to n. Here n is equal to lambda 1 plus lambda 2 and a is equal to alpha into 1 plus u is there. So your integration is alpha raised to lambda 1 plus lambda 2 upon gamma lambda 1 plus lambda 2 1 upon beta lambda 1 lambda 2 u raised to lambda 1 minus 1, and now the remaining these terms are your gamma lambda 1 plus lambda 2 upon alpha into 1 plus u raised to lambda 1 plus lambda 2. Now this term is get cancelled. Alpha raised to lambda 1 plus lambda 2 is cancelled with this term. So only the remaining terms are 1 upon beta lambda 1 lambda 2 into u raised to lambda 1 minus 1 upon 1 plus u raised to lambda 1 plus lambda 2, where u is greater than 0 and your parameters lambda 1 lambda 2 are positive. Now which is the PDF of beta distribution of second kind with parameters lambda 1 and lambda 2. That means u is equal to x upon y has a distribution beta second kind with parameters lambda 1 and lambda 2, where x and y are gamma distribution with parameters alpha lambda 1 and alpha lambda 2 respectively. Okay, these are the relationship between gamma distribution with beta distribution of second kind. This is the just simple relationship between them. Okay, now further we will see the one statement of relationship between distribution function of beta distribution of first kind with parameter m and n and binomial distribution. This is the just statement in your syllabus. Okay, so this is an very interesting relationship between the distribution function of beta distribution and the binomial distribution when beta parameters are positive integer. So suppose f ab denote the beta distribution with the denote the beta distribution function with left parameter your left parameter a, which is obviously positive, so a belongs to 0 to infinity, and right parameter b also belongs to 0 to infinity. Let g n comma p denote the binomial distribution function with trial parameter n is belongs to the set of natural number and success parameters p belongs to 0 to 1. Okay, if I have taken j from the set of positive natural number n plus and k, which is another constant, belongs to positive set of natural number, and x belongs to 0 to 1. Okay, these are the just assumption. If I have taken j and k, which is from the positive natural numbers, and x is lies between 0 to 1, then your distribution function f ik of x is equal to distribution function of the binomial distribution with parameter j plus k minus 1, 1 minus x of k minus 1. Okay, this is the just relationship between distribution function of beta distribution of first kind and binomial distribution. Okay, so these are the very simple and interesting relationships. Okay, further we will see the some nature of beta distribution. Suppose if I have to consider this is the density function curve, so then this is the your 0.25, 0.5. I have to just taken some. So here the value of x is like this, and this is the PDF. So if your x has a beta distribution of first kind with m is equal to 0.5 and n is equal to 0.5, then your curve is a loop like this. This is the curve look like this. Okay, now this is the straight line. Huh? You don't like this. This is the curve nature of the distribution or density function. Okay, so these are the just nature of distribution function. Similarly, if you have to consider the m is equal to 0.5 and n is equal to 2, then your curve is simply the exponential decreasing curve. For this, your curve is like this. Okay, if your m is equal to 2 and n is equal to 0.5, then your curve is reverse way like this. This is the nature of x as a beta distribution of first kind with parameter m is equal to 2 and n is equal to 0.5. If your x has a distribution beta first kind with parameter 2 comma 2, then your nature of the distribution is like this. This is the nature of distribution. Okay, so these are the just nature of beta distribution of first kind. Okay, so this is the our beta distribution unit is over. Okay, so thank you so much.